Our next speaker is Dr. Julia Lane. And Dr. Julia Lane works on Administrative Data Research Facility and is professor at the Center for Urban Science and Progress, CUSP, and the NYU's Wagner Graduate School of Public Service. She served as a provostial fellow for Innovation Analytics and senior fellow at NYU's GovLab. As part of the CUSP team, Dr. Lane works with research team to build CUSP data user facility.
Okay, I'm going to be like Frauke. It is impossible for me to sit down and talk at the same time, so but I will not move around since I know I have to be close to this. I'm going to talk a bit about the work that we've been doing that was funded by OMB and the Census Bureau at NYU and with University of Maryland and University of Chicago. So here's the issue, and I should provide some context here that I've been working in this field for quite some time. When I was at NSF, I provided partial funding for the DDI, and so have been worrying about metadata issues for quite a long time. When you're starting to talk about something like metadata, obviously the thing is what problem is it that's being solved, right? When you think about trying to describe what data are available and usable, we talked about alluded to a lot of the data that we're talking about are confidential microdata. There's limited capacity to work with data, largely. And then, when you're trying to share data, it's not just enough to put data together. People need to understand it and link it and work with it. So those are kind of the key challenges that I see as needing to be addressed. And so we kind of got stuck with this problem in spades when the Commission on Evidence-Based Policymaking got put in place because they were calling, OMB provided funding to Census to build an administrative records clearinghouse. So clearly the issue was you want to put data together in order to address policy issues. It's not just enough to put the data in one place, you have to be able to integrate them. Right? So it's not just a technical issue of providing a secure environment. You have to have people who are able to understand what the data are, how they can be linked, and so on. And so that was the genesis of the ADRF. But, as some of you in the room know, I've been working with administrative records for 20 years now, and administrative records, yes, they were a new thing in the early 90s, we're actually in 2018 now, and there's lots of other data, and Frauke alluded to this as well, there's lots of other types of data out there. So, if we're going to stand back and start building a place where you're going to link data from a variety of different sources, thinking that the only source of data that you're going to be working with is survey and administrative data is looking in the rearview mirror. So let's also think about the bigger types of questions. There's all kinds of other data sets that are out there. There's cameras, there's sensors. So the people down the hall from me, they're not thinking about American Community Survey type data where people are actually filling out a form in a fairly static environment. They're not even thinking about administrative records like wage records. Here's the kind of data that are being collected, for example, at CUSP, but lots of other places around the country. so this is Sonic, which is Sounds of New York City. Has anyone ever been in New York? Okay. How quiet is it? It's the biggest problem in New York is noise pollution, right? Because it's really noisy. You can't sleep. And it makes people really grumpy. That's why New Yorkers are grumpy, right? There's many reasons. So the problem that they're trying to face is the measurement of sound, measurement of the underlying problem is almost impossible to do because noise is ephemeral, right? And you can't really ask people how noisy is it because you have so much interpersonal variation in their perception of sound and so on. And you don't know what the causes are, and you want to be able to fix it if there's problems. So what they've done is they've put up sensors all around actually NYU, but spreading out to other parts of the city. And those sensors pick up information every 10 seconds. And what they're able to do is they tag some of the information so they know whether it's a jackhammer or a police siren or just someone throwing a party on Bleecker Street down the road from my apartment. And so you can actually tell what the noise is, and you can measure it and scale it, right? So that's so this is what these data look like. They're not in rows and columns. They're waves, and that's the raw data, but then people will take that raw data and they will convert it into measures. They'll take it from the actual streaming information, and then they'll take it and they'll turn it into measures, and those measures will change. Administrative data like Medicare, Medicaid data, because what you know is you have very detailed information about where people live, and then you see how sick they get or how grumpy they get, and then you can also tie it with their school information to see whether a lot of noise has affected the kids' ability to take care of them. And so all of this is a moving target, and people are going to want to do an solve for, we wanted to solve for, was how do you build documentation, metadata documentation, that is going to capture and provide us understanding of how people have used the data. So that's the core challenge that we're trying to answer. We're trying to describe data in some way that other people can find it and use it, okay? So how are we going to do that? So, of course, we had to build a technical environment, and there were lots of issues that we were going to try and solve for. We had to do data management, secure stewardship, analysis, and dissemination. I'm going to talk today, because we're talking about metadata documentation, we're going to talk about discovery and collaboration. And so here's the basic idea. I'm thinking about this issue as a ecosystem. And so you're not going to just solve for one dimension. You're going to try and think about what's this ecosystem going to look like. And essentially, really, there is so much information that is generated by data use, right? And as I'm using the data, the types of users are going to understand, learn different things about the data. Data producers have some information. We've heard eloquently from Dan and from Frauke, that data are being information about the data are being generated by the way it's produced, but there's also lots of information that is embodied in the people who've used it. So the secret is going to be, how can we figure out how to extract that knowledge, that tacit knowledge that is embodied in everyone who has worked with the data, and codify it, right? So that's a classic challenge. And so So what we've been building in the ADRF, we've got different modules. They all kind of talk to each other. And it's essentially building that ecosystem between the data user, the data producer, the data steward, and so on. Now, the way in which we have got that conversation going is very much training classes where you have the data producers also sending the people in the agencies who actually work with the data and try and induce them to provide the knowledge about the data that's in there. So I'm going to talk a little bit about what we did. So here's my inspiration. So back in the day when I was at NSF in the economics program, they put me in charge of doing the social behavior and economic sciences cyber infrastructure. So back in 2004, I got to meet, we were doing the review of the investments in e-science in the UK, and Carol Goebel had faced this problem with life scientists. So it turns out you've got life sciences who are working with life sciences type data, and you might have some information about the way in which the data were produced, but really there's lots of knowledge that is developed when the life scientists are working with the data, and they encode it in their lab books, right? But the problem is it's all in their head and they couldn't extract it. So what Carol did was she built something called Taverna. And what was so interesting about this, so this is about 15 years ago, she built it not by forcing people by building a set of rules that people had to obey, because people don't obey rules. Just tell my husband, right? I don't ever do what he tells me to do. But the basic idea is you don't set up a set of rules, you make it part of the workflow. And so by making it part of the natural workflow of the way in which people who were working with the data did, the data got documented and shared, and a community got built around it. So this original idea that she had got built actually into a whole suite of tools that enabled you to capture provenance and so on, because it was she started off with Taverna Workbench, and then it built up, and now it's part of an Apache suite. Think about it the same with computer scientists. So computer scientists share metadata about the work that they've been doing, and GitHub's a great example. And so essentially what they do is you share your code. You don't force people to go out and say you're going to document your code from soup to nuts. They'll provide code snippets, they'll provide information, and then they share it to the community. They get rewarded, and they, if you ever sit on a computer science panel or work with computer science researchers, on their CVs, they'll put on there how many followers, how many downloads, and so on. It's part of their culture. Here's another example: TripAdvisor. No one forces any metadata documentation on us, but it used to be that we wouldn't know anything about a hotel. We'd know it had windows and doors and things, but we didn't know anything about the insides of the hotel. But a robust community has grown up that provides metadata documentation about hotels and about restaurants, because it becomes part of the net. It's real easy to do, and I think Falco referred to that as well. Very easy to provide that information, and you provide rewards. So when you think about what's worked in other contexts, how can we make that work in our context, right? How can we bring massive, heterogeneous, different types of data together and induce the community to provide metadata documentation on a flow basis? So a couple of us, Brian Granger and Fernando Perez, who are the brains behind Jupyter Notebooks, and I got funding from Schmidt, Eric Schmidt Foundation, Overdeck, Alpha P Sloan, and another important donor who'd rather not be recognized for reasons I'm not going to tell you. So we've been funded to do some work on this. So here's the basic idea. The big thing is we wanted to build a secure data facility that's FedRAMP secure, and we were going to bring in administrative data, although it works for different sorts of data. We were going to bring in administrative data from different cities and counties and states and federal agencies, and the challenge is you've got the data, And the agencies are going to agree to share which people can share the data and what data can be shared, and they're going to work together in an approved temporary environment. That's the core idea. So we've solved, getting the data together in one place. Now how are we going to get them to provide information about the data? That's, in other words, how are we going to get them to provide the metadata documentation? And again, harkening back to the notion that we're going to engage them and make it part of their workflow. So what we did, as I said, the classes are kind of at the core of this activity, although it doesn't have to be. I'm just going to say that's the action-inducing event. So we had data on individuals and organizations and places. The structure of the class that Frauke and Raed and I built is the task is to join up the data sets and do analysis on them. And the advantage to the agencies is they get trained staff, they get new products being developed, so they're not doing it because they're being forced to do it, because someone's sitting there and saying, you have to do this, code, describe what that variable is. They're doing it as part of developing new products for their agency. And that's how they're going to develop new statistical indicators, which we're going to call metrics, okay? So we built the entire classes around the Jupyter Notebook. And for those of you who don't know what Jupyter Notebooks are, this was an idea that started in 2012. We were some of the first users, which is how I got to know Brian. And essentially, it's a computational narrative. So rather than there just being code, you've got the description of the code, you've got code cells, and then you've got the next piece and the next piece and so on. I'm going to show you an example. So it's a computational narrative that was built just for one person working on a data set and trying to solve a problem from soup to nuts. So it's essentially, in some sense, metadata documentation around the work that is being done. Okay? And it's taken off like wildfire. As I said, started in 2012. They're now dealing with millions of users. And what started to happen was organizations would come to them and say, we've got tons of data that we're trying to work with. Can you make Jupyter Notebooks that can be worked on by teams rather than individuals? Because that's how organizations do work, it's project teams. And so, and then particularly, most of them are coming in and asking to work with sensitive data. And so that's how Brian and I got going with trying to think about how can you make these computational narratives, which are bringing data science to individual projects, to organizations, so data science for organizations, which is team built. And so think of what we're trying to build here is Google Docs for working with data and sharing knowledge about data. Okay, so what we are building, we've been building these applied data analytics programs. People are trying to solve a problem, right? So it's like you don't just have data in the abstract. It's not like, oh, it's this abstract thing that we have to document. What you're trying to build is you're trying to use the metadata so that people can make use of the data for understanding how to solve a problem. So what you're then trying to do is build that knowledge around different sets of data sets. And Jerry's in the room. Jerry was the inspiration for our first set of data, which was around corrections. So, we had a set of questions in there which required sharing data. So it was basically, what is the impact of access to jobs and neighborhood characteristics on the recidivism of ex-offenders? So it required building data from multiple sources. And then it expanded to welfare recipients and so on. So taught the classes, put it all, you saw the example of GitHub, put the code in Jupyter Notebooks. And so now here's a typical Jupyter Notebook. You've got the code snippets, which when you click on them, it runs. You could tweak it. And now what happens is connect to the database. Okay, you see that in there? Now here's the problem that we immediately noticed is people land on the data set, and it's exactly what Mark said, precisely what they land on the data set, and they'd say, who else has done any work in this? Rather than starting from the bare bones, the big question is who else has used these data, with what results, with what code, and on what topics? So wouldn't it be cool if what you were able to do when you landed on that data set, you could pull up, and I'm going to wander, if you landed on this data set, on the right-hand side, you could pull up all the people who've worked on this data, what topics, what results, right? And then, just like Taverna, you say, isn't this cool? Wouldn't you like to contribute just a little bit to the community, just like the TripAdvisor, the Taverna type of approach? Okay, so that's what we're doing. So this is workflow-based metadata generation. So, and then the basic idea here is that when you land on a data set, there will be all that information embedded in as part of our data model. Okay? So let me give you a very primitive sense of what that means. So this is a picture of the ADRF, people working in the Jupyter notebooks. And so here's a very real example from the class that Jerry's people worked in. So this is someone from the state, and she's saying, here's this Department of Corrections data. She's working with admin data, which we had fully pulled in the data dictionary on. But now she's saying, what's going on? Is this junk data? So the CIO of Department of Corrections comes in and says, bad data. Right. So you can feed that back into the system as part of the workflow, not because you're forcing someone to do it, but as part of the conversation. And then the same person, she comes in and she says, has anyone tried to do this? And yes, someone's providing code. Feed that into the system. So it becomes like a coral reef of data. So again, you're pulling out the tacit knowledge and codifying it. Here's someone showing some other sample code. And then here's someone else saying, how is this data being used? How can we know about it? Here's a document. Now, as you're building that information, that's the kind of metadata. Obviously, it's important to have metadata by the way the data are produced. I'm not denying that. When you think of Amazon.com, the way in which, we had ISBN numbers, titles of books, authors, and so on, having that metadata documentation is critical to be able to order the book. But if I want to find out what's inside the book, it's people who have contributed information and voted about what's interesting about it and what's useful. And so this is kind of the vision here. So what we're doing is we kind of got 3 steps for this 2-year project of developing metadata augmentation. The first one is, let's do exactly what Mark said, and I swear to God, I didn't set you up for this. I didn't talk to him about this in advance. Let's run a competition, and let's take a whole set of documents, publications, where we know there's a data set cited. Okay, and we're using the ICPSR tag corpus for that. And then we'll get the computer scientists who know that there's a data set there to say, what's the semantic context around that? So that it tells you, it may not tell you perfectly, Mark, but it tells you this is a data set. It's the PSID of the ACS or the NLSY or whatever. And it's going to say, here's the language around it that tells me that that's a data set. Oh, and by the way, while you're looking at that document, tell me the methods and the tools, and I already have the authors. What that does is that gives me the rich context so that when people drop onto it, at least we've got some seed information about who, what, and what results. May not be perfect, but it'll be, all you have to do is get it started to start to get to the tipping point. And then we're working with NYU Game Lab. It turns out there's lots of people who know how to do games in New York City. So Tish and Steinhardt are really very good at this. So we're going to use the people in the classes, with permission, to be the guinea pigs to see what's going to trigger them to provide additional metadata, again, as part of the workflow. And so that's kind of the second, and then we're just going to iterate and so on. So that's kind of the timeline. I've got the competition that we're advertising with the computer scientists. The deadline is the end of this month, so I'm going to give you these so that you can help us advertise it, and that's, as I said, the first step. So essentially what we're trying to do is we're trying to, use the new computational approaches, be inspired by what other fields have done. We're not denying, as we said, that data sources and standards are important, but trying to engage the community so that you get data documentation generated by use as well as by production. Okay? And if you're interested in working with us with that, we'd be ecstatic. Okay? There you go. Oh, yeah, sure.
So when you're talking about data and people working with data and sharing information on the data set, one thing is the data is all public, another sensitive data.
Right.
So you can think of a case where people might be using internal American Community Survey data. You and I might get into a discussion on a particular data record or set of records that's unusual, and all of a sudden the conversation gets into maybe these cases were swapped, and that's why, and then that's
my word.
you would want out, right, in the public. So when you're looking at sensitive data, how do you, something we struggle, we have an internal wiki that's sensitive, where people can share that kind of information. We don't have anything outward facing because we can't police it.
Yes, so my experience of NSF is that wikis don't work particularly well, because they're not part of the natural workflow. So the way in which it's the same problem, right? Yeah. So basically, the way in which we all communicate outside is Slack, right? Because it's kind of like real time feedback back and forth. So inside the ADRF, there's Mattermost. So it's the exact copy of Slack. It has all the same. So people inside the secure remote access environment, it's isolated from the internet. Only people who are authorized can access it. And Mattermost is installed on each one of, so just to be clear, this is a FedRAMP secure environment, so it's like the city walls. And then each agency has their own house with their own rules for that environment, and then those rules propagate down into these temporary islands. So people within projects can communicate with each other. If approved, they can share with other people in other projects, but the protocols are, the approvals for who can share information on the Mattermost is restricted, depending on the approvals for the secure data. Who is authorized to be working on that particular set of data? That's a great question, but that's why this is not such an easy problem to solve. But that's how we're doing it. We're feeding those conversations into that secure environment. Those conversations only take part. Okay, thanks. Great.